お待たせいたしました。これより TE-04 The Philosophy and Design on AWS OpsWorks を開演いたします。講師は AWS Technical Program Manager トーマス・メティコです。Please welcome トーマス・メティコ。
Thank you. Konnichiwa, and sorry for the small delay. My laptop is particularly difficult. Sorry for that. So, as said, my name is Thomas, and I work for AWS OpsWorks in Berlin, Germany. So, our service team is actually located in Berlin, in Germany. This is our Skytree. It's way smaller than yours. I want to talk about the history first. So OpsWorks actually is an acquisition. So a friend of mine and we founded a company called Peritor. That company had the goal to consult and develop software for other companies. We ended up helping a lot of our customers to scale out, to move to the cloud, to work with AWS. And in the process, we found we repeat ourselves. We're doing the same job again and again and again. And we thought, hey, there should be a software solution for that that actually everybody can use. So in the mid of 2009, we started developing Scalarium and actually launched Scalarium in January 2010. Why did we build Scalarium? What was the reason? We wanted to empower our customers to move to the cloud in an easy and very powerful way. It should be really, really easy to move to the cloud, to automate, because automation of infrastructure in the end leads to very easy, fast, reliable, and secure deployments that you can audit. You always know who's doing what. Your infrastructure is completely a big living thing, is completely automated. This setup then enables you to change to business requirements, to develop faster, to be way more agile. Peritor with Scalarium got some attention from Amazon and actually joined Amazon with that idea and that software, and relaunched Scalarium in the beginning of 2013 as AWS OpsWorks. Since 2014, that little bit better flag of AWS OpsWorks is away. So we are live for 1.5 years now, generally available and out of beta. So what is AWS OpsWorks in detail, or what does it help you with? It helps you to model, control, and automate your infrastructure at any scale and any complexity. It is very easy to start. We offer you pre-built configurations, pre-built elements to use, and you can deploy your software very often, very fast, and secure. And the interesting thing is there's no additional cost with AWS OpsWorks. OpsWorks is a free service. You only pay for what you use through OpsWorks. Because of that, you might have seen like other management services Amazon is offering you. If we would imagine a scale from very easy, very convenient to a lot more control and detail, we would have on the one end of the scale AWS Elastic Beanstalk, which is a container-based model. You only develop your software and you drop your software in Beanstalk and just runs. You don't need to automate, or you don't need to deal with details around your infrastructure. It's really easy to go. And on the other hand of the scale, you have a very, very powerful solution called AWS CloudFormation, which is a JSON-based description of a larger landscape of infrastructure, so many different services and how they work together. AWS OpsWorks is, you can easily say, in the middle of these two roles. So it enables you a lot of automation and orchestration capabilities, but it still tries to be really, really easy to roll. Both services, AWS OpsWorks, as well as Elastic Beanstalk, you can use together with CloudFormation. So you can use CloudFormation to use through CloudFormation OpsWorks, as well as Elastic Beanstalk. And in general, you can use all of these services at once. You're not deciding for one if you don't want to. It's mix and match. Pick whatever solves your problem best. So you can imagine using CloudFormation to create OpsWorks tags together with the appropriate other elements like an SQS queue, a virtual private cloud configuration, S3 buckets, whatever it is you need together. So let's talk about OpsWorks and what it is in detail. The largest orchestrational element or the largest idea in OpsWorks is a stack. A stack contains all the infrastructure you have to solve a specific purpose. So that might be your production system, your staging system, something that is encapsulated. It can be your customer's A system, your customer B system. It is something that has a logical group. It is inherent. If you now would describe me your architecture, you probably would go to a whiteboard and draw little boxes. Right? I have a load balancer, I have application servers, and so on. All these elements you would draw on a single line, these what we call a layer. So a layer is a blueprint for all the infrastructure, all the servers that share the same purpose, the same idea. They have the same task. So the next level concept in OpsWorks is a layer, and a layer is a blueprint for the management of certain types of infrastructure, certain types of servers. So in that case, I have an example here where I want to use Elastic Load Balancing servers together with an Rails application server layer and a MySQL database server. The last step in OpsWorks you would have to do is just put the right components in there to put the right servers, the instances, in the right layers and start them. That's it. We then manage the infrastructure in that context for you. OpsWorks has built-in support for a lot of services that AWS is offering. Amazon RDS, Elastic Load Balancing, Amazon CloudWatch, AWS CloudFormation, AWS CloudTrail for auditing, very important and new, and AWS IAM stands for Identity and Access Management. So it allows you to create users and groups and specify who has access to what kind of systems. On the other side, we also support built-in layers with popular technologies. So for instance, we have a pre-built layer for HA proxy, which is a load balancer. We have pre-built layers for a Ruby or a Rails layer, Node.js, Java, PHP, a static web layer for static content, for Gang layer, which is a monitoring solution, Memcache for caching, and MySQL as a basic MySQL layer. The core and the idea how our service works is through the AWS OpsWorks agent. That little agent is a piece of software that is located on every instance. And that little piece of software understands certain commands. So we can send commands to that instance, and then the instance can react to it. That little agent also sends our service keep alive messages. So it basically says, hello, hello, right? And we know if the server is still healthy. And if it's not healthy anymore, we can automatically replace it for you because all the setup and all the configuration is automated. The last thing the agent is doing is it sends every minute 14 different host-level metrics that then end up in CloudWatch. And these 14 one-minute metrics are free of charge. So if you use OpsWorks, we give you some really interesting CloudWatch metrics for free on top. I talked about the events the agent understands. We have 5 built-in larger events. One is called setup, one is called configure, then we have deploy and undeploy, and shutdown. These are events that, through the life of an instance, are used to configure the instance based on its position in the life cycle. I will go through an example here where we would start with a simple application server sitting in an application server layer. We have the time from left to right as an axis. So you defined you want to have one application server, and then in the UI or via the API, you say, please start that server. So we launch the application server for you, and we trigger on that instance with that agent a setup event. And that setup event will make that plain vanilla server become the application server of your choice, of your definition. It will be a Tomcat or will be an Apache or whatever you want. It will become from vanilla to your specific desired configuration state, and it will be set up. After that setup, that little agent sends us as a service a log of that event with all the details, what happened on the machine. And we store that log for you, and you can access this log. As soon as this setup is completed and successful, we trigger the configure event on all instances in that stack. As it is currently one instance, we just do a configure on that one particular app server. That configure event in that case is probably a no-op. There's no change that is relevant for the app server, so it just happens and it's immediately done because the application server does not need to react to a change. But what we can do now already is deploy an application because we have a running web server. So we use the deploy event and say, there's my application source code, please put it on the instance. So we trigger that event on that instance. The agent knows what to do. It is getting the source code of your source code control system from S3 or wherever, puts it on the machine, and tells the application server if needed to restart. And we have our first running app online. But actually, what we want to do here is not a static website. It would be boring. So we need a database server. So we add a database layer and put a database server instance in that. And we launch the database server. Again, the similar event happens, but this time it happens on a different layer. So that launch database server event, that setup event, will not create an application server as before, but because it is in a different layer, it will create a database server. But then the same thing happens as before. We send the log, and we also inform again all infrastructure in that stack about a change to the stack. So what happens is we reconfigure the whole stack, and we send the configure event to all the infrastructure, to these two servers in that case. What will happen is different based on the layer. So on the application server layer, that configure event checks for the existence of a database server, and suddenly there is a database server. So it will reconfigure itself to actually know where the database is, so that application server now can write to a database. On the other hand, you can imagine that the database server configure event actually needs to grant access for that IP address of that new application server. So it will change its access control and add that IP address of that application server. So all that work, the application now knows where the database is. So what we will do is we deploy the next version of our application that now actually makes use of the database. Again, we trigger events, and based on the layer, different things happen. In that case, obviously, on the application server, we will check out the new version of the code, sorry, and restart the application server. So your application is really successful, and you need more application servers. So you just put another application server, sorry, another application server in the application server layer and start it. Again, I think by now you understood what's going to happen. We set it up, we send the log, and we trigger a configure event on all the infrastructure. And this time, again, the configure event of our old application server doesn't need to do anything. He already knows where the database is, right? But the database server in that case needs to grant access to another IP address. So it will understand that there had been one IP address in the access control list, but there's now two application servers, so it will add the other IP address to its access control list. Outside of that lifecycle, you at any point in time can execute any kind of script on any subset of server. So you can choose to just do something on all the application servers or just a subset of your application servers, and you can also select what to do, what script to execute. As during the night you don't have that much traffic anymore with your application, you can automatically let a server also be shut down at night or whenever you have traffic or no traffic. If you stop a server, we will have that fifth lifecycle event, that shutdown event triggered on that instance to shut down the server. And you can execute sending the last logs, or you can do something to clean up that instance. And at the same point in time, we will also inform the rest of the stack that there again was a change to the stack, and they will react accordingly. The application server might not care, because what does he care about other application servers? But the database, having currently in the configuration 2 IP addresses, will remove the 1 IP address and only have access left for that one application server you actually have. With that idea of these events and that life cycle, you can create any complexity in any system. If you would plan something like this, you probably end up describing a matrix. You have different events: setup, configure, deploy, undeploy, and shutdown. And you have your different layers. And then you would write, for instance, for my application server, in the case of setup, I need to install my application server, whatever server it is. But you write a script that creates an application server from a blank system. Or for the configure event of an application server, you would say, I need, in a configure event, so there was a change, I need to check if the database is still available, if it's still the same IP. And if that database actually changed, I might need to restart my application server, depending on the software you're using. And you will fill up that matrix with all the different events that have to take place in certain events. With the built-in layers we provide you, we have done that for you already. How does that work? So how does such a script look like? The agent we have on the machines, it is a wrapper around Chef. Chef is a configuration management software that is open source. And the idea is that infrastructure configuration or hardware configuration actually equals source code. You can write that as source code. That's the main idea of it. The beauty of it is that actually now your infrastructure is automatically, it's documented. It is versioned as it is code. You can version your code. It is testable and it's reusable. So you can reuse the scripts in different contexts. The main concepts of Chef are so-called cookbooks and recipes. A cookbook is a collection of recipes. The language in which you write these recipes is Ruby. That's their domain-specific language. But don't be afraid if you are not a Ruby expert. You don't have to be. I'm neither. There's obviously other management tools out there next to Chef, so it's not the only solution out there. If you want, there's actually a quite good site on the Wikipedia to compare all these different systems. So to show you that this is actually not really difficult, this setup recipe would install the Apache 2 package on a server. So that's all you need to write. And it would install an Apache 2 on a server where there is no Apache 2. Looks doable to me. So that keyword package here is actually a so-called chef resource. A resource is used to describe or define a desired state. I have another example here, the cron resource. And all resources have attributes and actions. So in the case of the cron resource, we have the attributes that specify at what point in time that job you describe here runs. And you have the action, which is create. So please create that cron job on the instance. The resource itself is programmed in a way in the background. You don't have to know that. You can see that source code if you want to, but this is programmed so that it works on any operating system. Right? So whatever software kind of operating system you're using, if you use that piece of code, it will do the same independent of the operating system. So that's the power of Chef. They abstract that. So going back to our recipe we started to write, we can make it a little bit more explicit. We can say package apache2 do action install end. Action install is the default action of the resource package, so we don't have to write it. The version before would have worked, but this makes it a little bit more explicit and readable. And in the next step, if you might know, actually Apache2 is the name of the project, but installing it on different operating systems actually requires different kind of packages. So if you would want to make that really independent of your operating system, you can create a so-called case statement, or if you want to. So you query which kind of platform you write on. So Chef is aware of its surrounding and of its situation. And in the case where you are on a CentOS, a Red Hat, or Amazon Linux, you actually will install the HTTPD package, which is their name for Apache2. If you're on an Ubuntu instance or a Debian instance, you will still use Apache2. So with that, you can slowly evolve and create more and more complex systems and more and complex recipes that are then actually running across any kind of infrastructure or any complexity, can react to any kind of change or situation. But what have we done here? We reinvented the wheel. Right? Installing Apache is nothing you might be an expert in or you need to be an expert in. Because of that, Chef offers you a vast variety of community-driven cookbooks. So similar with any other cookbook you have for your favorite dish, there's collections of them. Same is true for this. Your enterprise's core knowledge is probably not how to install Apache in the best way. In some situations it might be the case, but not all of them. So you actually can ask the community what do they think how it should be done, and use a community cookbook for that. On the supermarket side of Chef, so you see it's all a big theme there, supermarket, you can get over 1,500 cookbooks that are created by the community for popular technologies already. They all have ratings, like any other recipe would have. They have descriptions, and they have versions of these cookbooks. But not enough, you can also go to GitHub. If you look on GitHub, and popular open source code hoster, if you query a search for cookbook, you will return, or it will return over 10,000 repositories with cookbooks. Not all of them are Chef cookbooks, right? Somebody actually might put a real cookbook in there, but most of them are. And because it's open source, it might not be perfect, so you should check for issues and in GitHub language, stars, watches. You can always fork, so make your own version of it, or contribute back. The cookbooks we write as OpsWorks are also on GitHub. So the magic we are doing for the built-in layers, you can find there as well. It's all public. If you don't like what we're doing, you can help us making it better, by the way. Okay. How would you... So OpsWorks has support for a software called Bergshelf. Workshelf is a dependency manager for cookbooks. So if you're using a lot of cookbooks, you want to make sure they work well together. Right? You can't make like a sweet and a hot dish and they don't work together, and they you need to find it out. So you have a very easy dependency management solution on top of OpsWorks that is used by the community as well, and it's called Workshelf. And now I would go to a small demo that shows you how easy it is to actually deploy a new version. So, I need to restart my system here. Great. Okay, so this is my laptop. So I'm just a web browser. What I have here is my personal account, and I have 4 different stacks. And I will go to my photo app stack where I have a photo application already deployed. You can see I'm using 4 instances on EC2, and I go to the layers. And what you can see is that I use an ELB in front of a Rails application server layer, and that I need to update. And RDS is my database. So all of these are pre-built, out-of-the-shelf things we offer in OpsWorks. So there's no customization whatsoever needed. These 3 layers work together, and if I click on the ELB, I actually see, I see that there's a web application deployed. So going back here and saying, I have an application, my photo application, I changed the source code in the meanwhile, I want to now deploy a new version. You just press the deploy button. You say, yes, I want to deploy that application. I say, give a command so that everybody knows, everybody else knows what I'm doing here. And I press deploy. And now the step happens that I explained before. So we are contacting all the different agents and tell them, please do the deploy event. And they will then go through the process of a deployment. So they will get the code from, in that case, GitHub, because it's a public project, download it, unfold it, use it to create a new version of the app. And in the end, restart the application server or make the application server deliver the new version of the app. While this is running, I will show you something else. You might all remember the Heartbleed bug that was happening. Because we have that agent system and that configuration system, we can easily react on such a thing. So you could run a command that says, update dependencies, and would just update all the dependencies and do all the security updates on all of your infrastructure at once. If you want to be careful, you can do that on single instances as well. So as said, you can always select on which set of hardware or which set of servers to execute the event. So I give a command and do update dependencies. So I create a new event, another event for these servers. Going back to my deployment overview, to my single deployment here, and I see like 2 of my servers are already done, and probably the others are done in seconds as well. So just wait a little. Page should refresh, but I'm impatient. That's demos. So as said, we have monitoring. Yeah, you can see what's happening on the instances as well. You can drill into the different instances. You can see what happened over time. Going back to my deployment, should be done. Yeah, that was my deployment. And you see, deployment is done. It was successful on all the 4 servers. As said, for each event, you have a log. So this would be the log. That is actually what happens on an instance during a deployment. You can see all of that. So going back to my stack and going back to my load balancer, browser has cached it. Oh, awesome. So there's a new version of the app that actually uses the database now. right? And this app is actually allowing you to upload photos and rate them, and I think this was an awesome event and an awesome photo, so can vote that up or down based on that. So this was in deployment and a really easy way to do it, and that's the end of the demo. So I will continue with the slides, please. Thank you. So let's talk about cute little monsters. There's a project and a reference we have I can talk about that is called Monster World. The idea of Monster World is that this is a game, and that little Monster World is actually quite big. So Monster World has 7 million active users every month that play that game. They do 10,000 API calls per second, 200,000 database operations per second. And the impressive part is 10,000 of that database operations are actually writing operations to the database because it's a farming game. You create little trees and a garden and like this with your monsters. The cool thing is that this application is actually run completely by 2 engineers. That's it. Because they have, with OpsWorks, automated all of their infrastructure. This is a very simplified version of the architecture. You can find more details if you look for that company online. They have slides how their architecture actually looks like. But in the end, they use load balancers to balance across a scalable layer of application or game servers. And they use database masters and database slaves. And they can scale all of the layers because they have the automation in place that if they create a new slave database, for instance, it automatically gets snapshots from S3. So this makes it a really easy and effortless system to manage. This is the customer quote by Jesper, the head of engineering and chief of that game. They did it because they wanted to have a scalable infrastructure, a very flexible architecture. So as said, they have presentations online and how they actually change their database layer in a running environment, how they change technologies, although the game was running. They have to deploy very often because the game industry is a very fast industry. You have to kind of develop new features, new mechanics, new kind of gardening tools, whatever you do with your game. And they also can easily, with a single click of a button, create a staging environment. There's other use cases that are very common, which are, for instance, if you have on-premise hardware, but there's an upcoming large event, might be Olympics in 2020 or something, and you know that's going to happen, you can prepare a scale out. You don't need to leave on premises. You can scale out with AWS OpsWorks and automate the connection to your existing infrastructure to just for the chaos of the event have enough capacity in place. Another one would be to just move your test and dev environments to OpsWorks. We see that often, that companies are restricted in their database, in their data center, and they can't grow further fast enough in their data center. So an easy first step is always to move out staging, test, and development environments. And the cool thing is with OpsWorks, you can create as many as you want, as fast as you like. So you can clone an environment. So you have a new employee that is going to work on a new feature, you just press a button, and the stack, so the stacks I showed you before, you just create a new one. These are the features of the last 2 months. We launched support for different kind of new versions of software. We created some blog posts, how to use CloudWatch logs with AWS OpsWorks. Many things. And that's just the last 2 months. So we try to iterate fast based on what you think we need to do. We listen to our customers, and this influences heavily our roadmap. So what we currently hear a lot, or these are prominent recurring things, are that we should build more already provided layers. And the examples that are mentioned often are a worker layer or a Python layer. You can do all of that nowadays, but people want to have us build them. Official support for Red Hat. You can use Red Hat right now. You can bring your own Army ID, like your own Red Hat, but they want to have that built in. Or support for Windows is another common request. We don't support Windows right now. And there now and then is also, there's the ask for other configuration managers like Puppet, Ansible, or Salt. You can keep in touch with us through Twitter, so our service is on Twitter. We have a shared blog with Beanstalk and CloudFormation, where we share tips and tricks and new things to do. You can follow that for updates on our services. And we also have hands-on material in Japanese, how to create a WordPress blog with OpsWorks, if you like that. And the last thing, that's true not just for our console. On any console of AWS, on the bottom, there's a feedback button. And if you press that button, such a dialog appears. And then you can type in, please, I need support for this and that, or this is working really well, this is not working that well for me. And then you can press submit feedback, and it actually will generate a mail that I will read. Right? So all these mails go to me. Use it. I have a lot of mails to read then. And this helps us to define the future of our software, of our service, so that it helps you to solve your business problems in AWS. Arigato. Thank you very much.